Here I'm going to implement the Newton Raphson's method. Newton Raphson method in Python for a problem which is for the function f of x equals x minus cos of x. And in Newton Raphson's algorithm, we require the derivative. So f prime of x for this function is 1 plus sine of x. And the algorithm requires start with the initial approximation and the I plus first iteration xi plus 1, which is a value at the output of ith iteration. It will come from the ith iteration minus f of xi and divided by f prime of x of I, and that's it. Okay. This should be written with the curly brackets. Okay, fine. Now to start the algorithm, I required the NumPy library, NumPy as NP. It's here. Okay. Then I define the function f of x, and it should return a value. It should return a value x minus cos of x. So cos of x should be calculated from the library cos of x. And that's it. This is the given function definition. So with the green signal tick mark, we are sure that it is going to work. So now the derivative function f prime of x. So this should return a value 1 plus sine of x. So I'm attempting to write it in the most generic way.
1 plus.
Okay.
NumPy.
1 plus this requires the NumPy. Well, sine will not work, right? Yes. So that's why I'm testing it. Yes. You have to test each step, smaller step. That's the beauty of the interpreted-like languages. Now the algorithm specifications, right? So we have to start with the guess value x old for the time being, say 0.5. Then the tolerance level, for example, minus e power minus 3, right? And x new value will be calculated. X new value will be equal to x old value minus f of x old divided by f prime of x old. So this is there. Then we calculate the error. So error is equal to NumPy absolute of x old minus x new, right? And then we write things for the iterations, right? So this has to be repeated. So we say if error is greater than the tolerance level, then we have to do another iteration. So x old should be equal to x new, and the process should be repeated. Else we have to stop. We will call break, and that's it. So how many times should it be repeated? So for that one, I write a loop structure for I in range for several iterations, NIT. So here I define NIT, for example, 10 iterations, right? So for n iterations, pick up the old value, compute the new value by calculating the function value at the old point and the derivative value at the old point. So in Python, this will require the indentation. Okay. So new value is computed, error is calculated, and that's it. So just to see the answers, I write here a print statement. Print statement. In the print statement, I would like to return the I value, iteration value, X old value, X new value, and what else is required? Well, nothing is required. Okay, error. And correspondingly, the format should be provided. And the I, it's integer, so 4D, then 3 real numbers. So I write here percent 10.6F, percent 10.6F, and percentage 10.6F. Right. Okay. So print statement is there, and also it is like this. So after that, we can write another statement. If okay. Well, before breaking that loop, we can write a message for the user. Okay. Well, no. If error is greater than tolerance, then break. Otherwise, complete the number of iterations. Yes, that's perfect. Okay, let's test this one up to this point. So there is no warning, nothing. So we have the answer 0.7391. It has been converged to 3 decimal or even more than that. To make the titles, I copy the print statement and write it one more time here. And now I identify this one. I is for the iterations, iteration number. X old is X old. X new is X new. And error is error. Okay. And on this side, these would be replaced by the string format 10s, s, 4s, right? So if you like, for also, let's see for more iterations, finer convergence. So it is there, right? Newton Raphson's method. If you like to write its function, so pick up this structure. And define the name, define function Newton, and it requires a function to be specified, its derivative to be specified, x old to be specified, x old, and the number of iterations to be specified, how many iterations to be done, and after that, paste everything, right? It will pick up the rest of the things from the program inside, indent, and finally the return. What do you like to return? So return value of number of iterations performed, the X new value. Okay, that's it. So no warning, nothing, no problem. So now from the function, so Newton, it requires the function f prime, x old. I can give an x old 10, not 10, 1 is fine. And number of iteration, say 50 iterations. So it returns the answers. So now this is a generic function. So you can use this program for some function g, g prime, x old, and all that, right? So with the guess 2, not 2, okay, 20, a bit weird. So it has converged, right? So with this one, this demonstration concludes. Newton Raphson method is the fastest method that approaches to the solution of a nonlinear equation. And this method is then extended to the higher order nonlinear system of equations. So let's stop at this point. Take a deep breath. It calms the mind.